almost like a pitch from this. So CoronaWhy task time series is essentially uh, a subgroup of CoronaWhy, and we're primarily focused on using the latest techniques in time series forecasting to forecast the trajectory of coronavirus. Why also designing kind of a broadly applicable suite of deep learning for time series forecasting tools that can also work in other contexts and solve both humanitarian and business type problems. So we have four kind of main project or deliverables that I'll talk about in detail. Um, Even though like our first one's the only really COVID-19 specific one, the other three all like play into our COVID forecast. Um, and the good thing about them is that they would work in other kind of contexts too, which is why they're valuable for I believe a wide range of businesses and other sorts of entities. But I will get into our actual COVID stuff first. So we'll look at this our COVID county projections dashboard. So one of the main problems with current COVID models, and this was actually highlighted by the former U.S. chief data scientist, is they work mainly kind of at this very high resolution. They're either at like a state level or a country level, and they don't give a lot of insight into how a specific county would deal with the virus, or even lower granularity would be good. And we are looking to work towards that. But right now, we're primarily focused at the county level. Um, the other major problem is they don't really leverage this kind of observed data very well. So, as he says here, like a lot of them are based on like pure kind of statistical, like theoretical, like visions of the virus, and don't actually leverage the actual COVID data we have. Um, and yeah, and they don't. And a lot of them don't consider kind of like demographic distributions and things like that. So the good news is actually our models do a lot of this stuff already. So our models are specifically aimed at forecasting at the county level. Um, our model forecasts when they're deployed to production, they will be updated daily with the most recent COVID data, and we plan on having a system to automatically retrain our models on a weekly basis. Um, uh, Also kind of a core idea of our models is that like we're incorporating a wide variety of data sources. So we've spent a lot of time constructing a very good COVID data lake and are still kind of working on that with our data kind of engineering subgroup at CoronaWhy. So we plan on incorporating additional sources of data, such as stuff from geospatial, textual data from social media and other stuff, symptom surveys, all to improve our model's ability to forecast using this full range of data sources. So in terms of that, what this will actually look like in practice is we plan to have a online web app dashboard that essentially would answer the following questions: What will you know our county's hospitalizations and case counts look like 16 days from now? Also, we're looking to do like basically these types of causal inference. So basically, if my county took this action and implemented this policy, how would that affect the projections and case numbers? Also, what we're looking to say is like provide interpretability for both epidemiologists and public policy people, as in saying what are the factors that like the model thinks are currently driving COVID spread in your community. Um, Finally, we do have plan to have some support for counterfactual kind of interest inference. So, like historically, if my county had done this at this point in time, what would our case numbers and hospitalizations look like now? And then also as kind of an interesting thing is we do have mobility data. So actually businesses could make use of the mobility data to that we plan on having to see how that might impact their businesses and things like that. And we do plan on maybe even training some models that, based on a policy, would forecast kind of the change in mobility in different places. So this was obviously valuable for a wide group of people, mainly epidemiologists, public policy people, even business owners, and also just people concerned about the virus in general. So that's kind of our main COVID 19 related deliverable. Um, our next three things are kind of things that all play into delivering that, but then can also be generalized to other industries and areas. Um, so the next main thing is our time series forecasting platform, and so with that, that basically um, wide variety of industries, humanitarian efforts, etc. Being able to accurately forecast various temporal trends is crucial. As you know, this repository previously forecasted things like flash floods, droughts, and things like that. So that's obviously a big one. Health, other medicine and health things. There's a ton of things that could be done. We just don't have the data for. But patient responses to treatments over time, readmissions to hospitals, operating room utilization. Things like in agriculture, like crop yield, crop demand, milk production. Tons of stuff in retail. I actually worked at a retail store a while ago. One of our big things was forecasting demand for specific product SKUs to be able to determine hourly stocking. Um, Manufacturing, finance. I mean, basically, almost every kind of industry or group, there's probably some need for models that can really forecast and predict temporal trends very well. Um, but like what I've seen is a lot of companies really struggle to get good temporal models. Time series forecasting and predictions actually a very hard task. And part of the problem is that particularly when doing kind of like deep learning for it, there's just so many different hyperparameters and other things. But at the same time, deep learning can be very effective in it because it can synthesize multiple kind of modalities of data you wouldn't normally synthesize. For instance, here we're looking at synthesizing geospatial data, demographic data, using these autoencoders into the temporal forecast. And similarly, like I think that a similar thing could work really well for forecasting demand in stores, like using those like autoencoders to form a county embedding, and even using geospatial or even traffic data to kind of improve the accuracy of what hour stuff will be bought. So deep learning does have a lot of benefits over kind of basic statistical models in this area, particularly when you acquire a lot of data sources. Nevertheless, it remains really hard, particularly to discover the causality and kind of trends in your data. So Q flow forecast. So yeah, as I said originally, this was used for flow forecasting in COVID, but it's now been applied to COVID and actually some other interesting problems. The idea is we have basically a very unified, coherent platform of all the different state-of-the-art time series models, loss functions, and we have different layers we can swap in and out for both forecasting, classification, even just anomaly detection. We have very very specific documentation where it shows how easy it is to swap out and test different hyperparameters, and we employ the latest kind of interpretability methods, as those have historically kind of been a weakness for deep learning and time series, because you have to be able to just explain your decisions to stakeholders in the business. And then the other idea is to use these easy to use transfer learning through config files and really leverage the power of positive transfer across temporal dependencies. That's also kind of one of our research objectives, but it will play a major role in the platform in that people will be able to just leverage transfer across a bunch of different time series very easily to improve their results, just like how everyone does it kind of like with ImageNet nowadays. So also a core part, as I was saying, was this idea. for flow forecast is this ability to synthesize multiple modalities. So the REPA will include methods to embed this different types of modalities and feed it into a time series prediction problem. Um, and then it will also, just make it really easy to synthesize all those different types of, geospatial, textual, other imagery data into your model's forecast, and leverage those. It'll also make it easy to incorporate kind of multi-horizon temporal forecasts where you might have some data coming in at the daily level, some at the weekly level, and things like that. For instance, if you're like predicting like I don't know, like patient response to treatments for a tumor or something, you might only have uh, images of that on like a monthly basis, but you might have other things like patient vitals on the like weekly basis or something like that. So there's really a lot of these kind of multi-horizon problems where in retail too, where you might have uh, just updated like shipment info for on a monthly period, but then you have the demand sales on a daily period. Um, so yeah, there's a lot of those potential use cases. So that was kind of the first two. The third is designing kind of an overall multivariate data lake and weight storage place. So key idea here is that public data can enhance performance of forecasts. Um, like a lot of, for instance, a lot of things, even just like predicting, like if, like for instance, uh, an appointment someplace will be canceled or not. Weather data can play a huge role. Also, predicting, like obviously, if you're predicting rides or traffic, weather could play a role. Similarly, actually, too, with COVID's actually broke down a lot of current time series forecasting models because it's such an anomaly. So, in a sense, actually having that case data and other stuff in a central kind of data lake that people could even just join to their time series data would be really useful because then they might get better performance out of their forecast models. So the idea here is, um, but yeah, there's kind of a problem in dealing with that data now because a lot of it is really a pain to join together. You might have different date times. Um, uh, and stuff like that. Also, as I said before, with the transfer idea, you want to maybe leverage existing model weights. So the idea here is to have this really cohesive multivariate time series data lake, which could be used for transfer learning, joining time series together to improve your models. It would have clear data dictionaries, standard date times, and pre-built queries to make it easy and see if it would join and improve the performance of the model. And similarly, we'd have a store repository of kind of model weights that could be used as a starting point. Didn't quite finish that slide, but I do think actually probably unlike with NLP, some of the like transfer and the time series forecasting case will be only from like time series, so there probably won't be just like one general weight thing. So like people could even like browse the most relevant weights, pre-trained weights, and see which they think would be most relevant for their task and try out kind of a plethora of those. That's kind of what people already do on the BERT website, actually, even a bit for NLP. And then also a native kind of integration with Flow Forecast. So Flow Forecast would easily be able to pull from this temporal data lake, which I'm thinking right now would probably be on BigQuery. Um, but anyway, so that's the third. The fourth is um, obviously plays into these other two, but it's this idea of having a kind of rapid experimentation platform that moves away from the tediousness and problems with reproducibility with notebooks. So as of now, around 87% of machine learning models will never make it to production. There's mainly this actually centers around problems with reproducibility, deployability. There are some reasons for that we can't control, like poorly aligned with business interests, but we can help address the problems with reproducibility and deployability. So the idea is we have an overall AI experimentation framework which would be compatible both with our main repo and other popular repos not even related to time series. Basically, experiments would be spun up based on a GitHub PR. After they're spun up, there would essentially be log to weights and bias linked to there, so that it would automatically link that to the PR. And then basically, the nice thing about this is all communication with the experiment results, etc., would all take place in the PR, and you'd see the config file quickly. And then the idea is the PR would be merged to like dev, which would contain a historical record. And then basically, if the performance is good, then basically there would be a prod branch where the model is where you would merge then the PR and the model, and then basically the ensuing GitHub action would take care of the whole deployment process, and basically then just deploy the model to actually run on production on some cloud provider. I'm still working out how the exact details of that would look, but that's the idea. So yeah, I didn't finish our team page. I don't know if Arthur wants it, but that's kind of like the overview of the stuff. So, does anyone have any questions or feedback on that?
Nothing.